in the question it is asked which one of the following is an inner orbital complex as well as diamagnetic in behavior, and their atomic number are given here. First, hexamin zinc 2 ion. So, in this complex zinc has +2 oxidation state and its electronic configuration is 3d10. And if we write this in orbit, in the orbital, that is 3d, 4s, 4p and 4d. So, if I fill the 3d electrons here in the orbital, then here 10 electrons are there. So, all the d orbitals are occupied, and so that this complex can form only the outer orbital complex sp3 d2. And if you look at the electrons, they are paired up here. So, this is diamagnetic in nature. So, this complex is outer orbital and as well as it is diamagnetic in behavior. And so that, but here they have asked to find out an inner orbital complex. So, this is not the correct answer. So, this is wrong. And if I take this option, that is hexamin nickel 2 ion. Here nickel has +2 oxidation state and its electronic configuration is 3d8. And if we write this in orbital, (4s), 4p, (4d). So, if I fill the 3d electrons here in this 3d orbitals, then 6, 7, 8, and here 2 unpaired electrons are there. The ligand, which is actually ammonia, here it is a strong field ligand, and in the presence of strong field ligand like ammonia, these unpaired electrons, they can pair up. But if this will pair up, there will be only one 3d empty orbital, so it cannot form d2 sp3 hybridization. So, this will not get paired up. So, this can only form the outer orbital complex, that is sp3 d2. So, this is outer orbital complex and it is paramagnetic in nature. This is also wrong, since in the question it is asked to find out an inner orbital complex and which is diamagnetic in behavior. And if we take the third option, that is the complex hexamin chromium 3 ion. Here the chromium has 3 plus oxidation state, of which the electronic configuration is 3d3, and if I fill the orbitals 3d orbitals and 4s, 4p, (4d). Here if I fill the d electrons here in this orbital, then all the electrons are not paired up, they are unpaired, and in the presence of ammonia they will make bond here. So, D2 sp3 hybridization. So this is actually inner orbital complex, but it has unpaired electrons, so this is paramagnetic, not diamagnetic, so this is also wrong. And if we take the option, the complex hexamine cobalt 3 ion, where the cobalt has oxidation state of +3 and its electronic configuration 3d6. So if you write them in the orbitals, 4s, 4p and 4d. So there are 6 electrons are there. So if I fill them here, in the presence of a strong field ligand like ammonia, it will get paired up, so that hence it forms an inner orbital complex. And if you look at the d orbital electrons here, they are paired up, they are diamagnetic in nature. So as it was asked in the question, it is an inner orbital complex as well as diamagnetic in behavior, so the option D is correct.